You believe you know what you're asking when you say, "Why do magnets repel?" You don't. And until you understand why your question is flawed, every answer will leave you frustrated. Grab two magnets. Feel that invisible push, North Pole to North Pole, in empty air. You want a reason. You want me to compare it to rubber bands, springs, or hands pushing something you already grasp. Here is the truth. There is no familiar comparison. I'm not being difficult. Magnetic force is fundamental. It is rock bottom. There is nothing simpler underneath it to use as an explanation. Asking why magnets repel is like asking to explain numbers using something more basic than numbers. It can't be done. You might think you've heard explanations, magnetic fields, spinning electrons. Those are not why answers. They are descriptions, very precise, but descriptions nonetheless. They tell you how the force behaves, not why it exists in the first place. Consider this. Push your hand on your desk. Why doesn't it pass through? You might say, because the desk is solid. But that's just a label for what you're trying to explain. Atoms are mostly empty space. If an atom were a football stadium, the nucleus would be a P at the center. Your hand and the desk are essentially emptiness. So why don't they merge? The answer is electromagnetic repulsion between electrons. Same charge particles repel. The solidity you feel is trillions of tiny electromagnetic pushes. Now the real question, why do like charges repel? You can't answer. Saying because of the electromagnetic force is just giving it a name. It's circular. This force is one of four fundamental forces in nature. It is not caused by anything else. It just is. And here's what's crucial. The force stopping your hand from going through the desk is the identical force making magnets push apart, not similar, the same. Why does one feel normal and the other mysterious? Because you've experienced electromagnetic repulsion at atomic distances your whole life. You call it solidity. With magnets, the gap is visible, a centimeter of empty space, so it feels strange. The weirdness is in your psychology, not the physics. Nothing ever truly touches. It's all repulsion across gaps, just at different scales. You might hope quantum mechanics explains the why. Quantum electrodynamics, QED, is our most precisely tested theory. It tells you how to calculate interactions with stunning accuracy. But it does not tell you why the force exists in a philosophical sense. It describes perfectly but does not explain away. The chain of why must end somewhere, and it ends at fundamental properties of reality. We don't start with philosophy and derive the universe. We start with measurements. We find patterns, write equations, and test them. Understanding in physics isn't about philosophical comfort. It's about predictive power. By that standard, we understand electromagnetism profoundly. We can calculate an electron's magnetism to 11 decimal places. We build MRI machines, motors, and computers with it. Your intuition evolved to navigate a world of medium-sized objects, not quantum fields. When physics reveals something that violates that intuition, like action at a distance, you have a choice. Reject it as unsatisfying, or expand your intuition. Learn the mathematics. Build new mental models. So when you feel magnets repel, don't ask why, ask how. How does the force change with distance? How can we calculate it? How can we use it? These questions have magnificent answers. What should truly awe you is not that we can't reduce magnets to springs, but that we can reduce the complexity of almost everything. Light, chemistry, the structure of your body, the shine of stars to this same electromagnetic force. The universe operates on a small set of rules. The search isn't for a comforting analogy, but for a unifying structure. You wanted me to explain magnets by comparing them to something familiar, but the more profound truth is that everything familiar is electromagnetic. Your desk, your senses, life itself, all are manifestations of this force. You are not separate from the magnets. You are made of the same thing. That invisible push you feel is one of the foundational threads of reality. It's not a mystery to be solved away. It is a fundamental piece of the cosmos to be understood on its own terms. And that understanding, precise, predictive, and powerful, is what we truly have. And it is enough So, we've arrived at a humbling conclusion. The force that pushes magnets apart isn't a unique anomaly. It's the universe's most prolific conversationalist, whispering in the spaces between every single atom in your body right now. This understanding shifts the goal. The pursuit is no longer to find a comforting, familiar analogy. The pursuit is to become fluent in the language itself, the language of fields, forces, and mathematics. But let's be practical. If Y is a dead end at the fundamental level, where does that leave us? It leaves us with something far more powerful: application. This is where the abstract becomes tangible, where the fundamental force you feel in your hands becomes the engine of civilization. Think about it. Once we accepted that we couldn't explain electromagnetism in simpler terms, we focused instead on describing its behavior with impeccable precision. And from that description sprang every piece of modern technology that defines your life. The motor in your fan, the generator at the power plant, the speaker in your headphones, the hard drive storing this information, all are deliberate, engineered manipulations of the electromagnetic force. We didn't need to know why it exists to harness its power. We only needed to know how it behaves. This is the true engine of progress. It's the move from mystification to methodology. When you shift your question from "Why do magnets repel?" to "How can I use this repulsion?" you step out of the audience and onto the stage. You become a participant in shaping reality. Consider the other fundamental forces. Gravity bends space-time to keep planets in orbit, but it's electromagnetism that shapes the planet itself. The strong nuclear force binds protons in the heart of an atom, but it's electromagnetism that dictates how those atoms link to form molecules, metals, and DNA. The weak nuclear force governs radioactive decay, but it's the electromagnetic radiation that allows us to see the stars born from that decay. Electromagnetism is the bridge. It's the force that mediates between the subatomic quantum realm and our macroscopic classical world. It's the translator. So when you feel that magnetic push, you're not feeling a parlor trick. You're feeling the operational backbone of reality. This brings us to a final, crucial point about wonder. The initial mystery of magnets feels like a magic trick, an exception to the rules. But the real, profound wonder is not in the exception. The real wonder is in the rule. The awe should come from the fact that this same singular rule, expressed through Maxwell's 4 elegant equations, governs the nerve signal in your brain, the light from your screen, the heat from your stove, and the structure of a galaxy. The universe isn't a bag of disconnected magic tricks. It's a symphony played with a very small orchestra. The magic is in the harmony. So, what's the next step? You have 2 magnets in your hand and a universe of connection in your mind. The invitation now is to play, not just with the magnets, but with the ideas. Test it. What happens when you introduce a piece of iron? What happens when you move them faster? Can you build something simple, a compass, a levitating pin, a primitive motor? This play isn't childish. It's the first step in the scientific method: interaction, observation, and refinement of understanding. You wanted an answer that made magnets seem normal, but I'm offering you something better, a lens through which everything else seems extraordinary. The solidity of your floor, the color of the sky, the warmth of sunlight, all of it is a continuous, dynamic dance of this force. The mystery of magnets was merely a doorway you've walked through. Now you're in the grand hall of physics, where everything is connected, describable, and waiting to be explored. The conversation isn't over, it's just begun, and now you know the language.